Hello everyone. So in the previous class we were studying hypothesis testing. Okay. Hypothesis. What I called it as a statement. Okay. And we are available with data. That's what we have collected. And the collection we followed a process. And that process may be a survey. One of the process I'm just talking about that is a survey. Okay, fine. So you want to prove whether a statement or hypothesis is correct or not. So this phenomena comes under statistics, that is called as inferential statistics. Okay, inferential statistics is divided into two categories. One is descriptive, another is inferential. Okay, whatever you have learned so far that came under descriptive: mean, median, mode, measure of central tendency. All these things are under descriptive because I'm going to describe about the data. What is the maximum value? What is the minimum value? Okay, and quartile, quantile, all these things comes under descriptive. That means I'm describing data. Once the description is over, now I want to make inferences. That means I want to write an hypothesis over it. Okay, so hypothesis testing, we are available with a population, entire population, complete data. We do pick up a sample from the population. Okay, and we do perform analysis on this sample only. Okay, because performing analysis on entire population is difficult. Okay, getting that much data is not like easy task. So do analysis over a sample. Since we are having time constraint, okay, we have to give a quick result, so we can't do the analysis over entire data, so we are working on sample. If the sample size increases, your distribution gets converted into normal. You very well know about that. If I make a distribution of sample, that will be like a student t. If I make a plot for the distribution of population, that will be like a normal. And if the sample size increases, it will turn up into a normal distribution according to central limit theorem. Yesterday only you studied. Okay, and I can have many samples: S1, S2, S3, S4. I can have many samples. And if I make the distribution of samples, that will be normal according to the theorem CLT. Yesterday only I taught. Okay. So you have to perform testing. Okay. Over sample of data to check whether the hypothesis given is correct or not. Whether this hypothesis, this statement is applicable to entire population or not. See, I am working on sample, but whether this hypothesis is applicable for the entire population or not, this I am going to prove by taking a sample. We are having, we do face For example, disease. Okay, disease. Okay, so the doctor do take sample only, na? And they do experiment over the sample, and whatever be the medicines they give according to the sample only. दे डू कलेक्ट डिफरेंट डिफरेंट सैंपल्स. ऐसा थोड़ी ना कि आपसे पूरी एंटायर सभी को बुला लिया. सबको तो नहीं बुलाते वो. सैंपल ही कलेक्ट करते हैं. इफ आई नीड टू हैव अ ब्लड टेस्ट, सो द डॉक्टर विल नॉट टेक माई एंटायर ब्लड. दे विल टेक अ सैंपल ऑफ ब्लड, and over that sample whatever the result came, it will be applicable for throughout the blood, whether what kind of issue is been there. तो कलेक्शन ऑफ सैंपल ही होता है बस. इसी के बिहाफ में जो कुछ कहना है कह दो. Want to say anything? Do speak over the sample of the data. Okay, fine. So yesterday I told we are having H0 and HA or H1. H0 is null hypothesis. Null bole to that hypothesis only. It's null hypothesis. That means that statement only for which we are doing a check. H0, H1 or HA is alternate hypothesis. Okay, that means if null is not true, then obviously alternate is true. Okay, then I told that you do have confidence level and significance level. That's how you have made a distribution, normal distribution, and this region came into significance 5% and rest 95%. That is confidence. Then confidence is that okay, how much confident you are over your experiment, that you will say that this hypothesis is going to be true. Okay, how much confident you are that this hypothesis is going to be true. So there are some standards: 95% and 99%. You are 95% confident or you are 99% confident. So 99% confident, so 1% significance. 95% confidence, so 5% significance. Okay, this is how we give the values. Okay, and actually there is a p value, probability value, p value, and we do check p greater than equal to 0.05, 5% na, greater than equal to 0.05. And what I said about that p yesterday, that if the value of p is less than significance, that means less than 5%, that the null hypothesis is rejected. Okay, if the value of p is less, if the value of p is less than alpha significance, the null hypothesis is rejected. That means we are having a strong evidence against null hypothesis. And if the value of p is greater than alpha, then we are going to accept the null hypothesis. Okay, that means you are in a confidence region. Don't worry. The null hypothesis is accepted. That's what I taught yesterday. Okay, so let me share my entire screen. And it's a very interesting topic, this hypothesis testing. Okay, fine. So, based upon the results, based upon the value of p, probability value, what it is, I will let you know ahead. We'll do some example. We'll pick up some hypothesis testing algorithm. So, if the null hypothesis is rejected, it suggests that there is a sufficient evidence against the null hypothesis, and we are going to accept alternate hypothesis. And if the null hypothesis is not rejected, then obviously you are going to accept it. Okay, so everything depends upon the value of p. Okay, so if the p is greater, if p is greater or equal to the significance level, there is not an enough evidence to reject. But if the value of p is smaller than alpha, then we can reject. Okay, got it. So in this regards, I am having one algorithm that is called as ANOVA, analysis of variance, famous algorithm, hypothesis testing, famous ANOVA. I hope you have heard this thing, ANOVA. So name suggest analysis of variance. भाई वेरियंस के बारे में उसका आकलन करो वेरियंस का. You have to analyze the variance. अच्छा, वेरियंस का एनालिसिस करना है. कैसे करना है भाई वेरियंस का एनालिसिस? How you are going to analyze the variance? What is variance? Variance will say sir distribution of data, sir. Variance means how a data point is away from its mean. That is variance. How much far a data point is from its mean. That is variance. And I need to analyze it. कैसे करेंगे? How? So ANOVA is a statistical hypothesis testing technique to determine whether there is any significant difference between the mean of two or more group. अच्छा, तो भाई अभी थोड़ा सी बात समझ में आई. क्या समझ में आई? What we got to know here, that sir, we do take various samples from the population. For example, this is sample number 1, this is sample number 2. We are having two samples. We took two samples from the population. टेस्टिंग, हाइपोथेसिस टेस्टिंग, आई गेस वो बोल रहा है कि आप इन सैंपल को पकड़ो यार, इनको पकड़ो आप सैंपल को, जस्ट पिक दीज सैंपल्स एंड चेक द डिफरेंस बिटवीन देम. Check difference between these samples, between these samples, how they are behaving. You did perform random sampling. This is random sample S1, random sample S2. You collected random sample. Now check the difference between the behavior of these two samples. क्योंकि हो सकता है भाई तुम S1 की बिहाफ में कुछ कह दो, वो गलत निकल जाए. Okay, you do speak something on behalf of S1, so only one time sampling is not enough. No? This may give you wrong result also. So you collected another sample. You may collect another sample. You may collect another sample. बहुत सारे सैंपल लेना पड़ेंगे. ऐसा थोड़ी ना कि मैं किसी एक का सैंपल ले लिया और बोला कि हाँ ठीक है यही प्रॉब्लम है. If I'm going to if I'm going to make a medicine for a disease, it doesn't mean that I'm going to collect only one sample. I will be collecting different people sample. Then only I will understand what actually the issue is. Now, what is the difference between these two samples? That is the question. That's what comes under ANOVA, analysis of variance. Okay, so what it said, ANOVA. Uh, what is the difference between the mean of two or more group? That means two or more sample. What is the difference? Okay, fine. So there are certain steps involved in ANOVA and they have written here the step. तो ये तो अभी पढ़ पुढ़ा के कोई बताने का कोई मतलब नहीं है भाई, पढ़ क्या है ये. ठीक है, आई एम नॉट गोइंग टू रीड those steps. Let's talk in detail. Advantage, disadvantage, I will let you know. Let's first talk in detail about ANOVA. ANOVA. So it is a statistical hypothesis testing technique that is used to find the difference between the mean of of two or more groups independent. एंड विल ड्रॉ सम कंक्लूजन. अच्छा भाई, क्या करोगे फिर, तुम कैसे कंक्लूजन निकालोगे? So in an ANOVA test, we have to find if a survey or experiment results are significant or not. Okay. Now let's define a null hypothesis H0. And the null hypothesis says that mean of each and every sample is equal. All population mean, all sample mean is equal. This is null hypothesis. अब भाई ये पॉपुलेशन बोल रहा है, तुम कंफ्यूज मत करना. सैंपल समझ लो, यू कैन अंडरस्टैंड इट एज अ सैंपल. सो यू आर हैविंग एंटायर पॉपुलेशन. You collected sample S1, you collected sample S2, you collected sample S3. According to ANOVA, according to the null hypothesis, it says that mean of S1, mean of S2, mean of S3 equal. Mean of each and every sample is equal. ये भाई कहता है null hypothesis. तो अल्टरनेट क्या कहेगा भाई? अल्टरनेट उसका उल्टा बोलेगा. What the alternate will say? Alternate will say opposite of the null. Alternate will say not all the mean of the population are equal, or not the mean of all the sample are equal. There's a difference in the mean. That means at least one sample or one population is different from rest. बस यही है अनोवा. इतना इतना है ये. Only this thing is ANOVA. Null hypothesis says mean बराबर, mean is equal. Alternate says mean is not equal. यही ANOVA है. Okay, let's see. देखते हैं, प्रूव व्रूव करते हैं कुछ. So in statistics, null hypothesis and alternate hypothesis, they both are in competition with each other, because statement, hypothesis is a statement. We have to draw conclusion about the population based upon the sample. Okay, so based upon the sample, I will talk about the entire population. Okay, fine. So null hypothesis, you know what it is. Initial assumption. That is null hypothesis. Initial assumption, initial statement. And according to ANOVA, it says that there is no difference in the mean of the sample. S1, S2, S3, भाई जितने भी सब सैंपल है ना, सबका मीन बराबर है. वो ये कह रहा है null hypothesis. That is a statement of null hypothesis, that all sample mean are equal. Okay. However, alternate hypothesis H1 or HA contradict, and it challenge the null hypothesis. It says that नहीं है भाई, नहीं है. Okay. The mean is not equal. That's what alternate hypothesis says. Now who is correct? कौन सही है भैया? कौन सही बोल रहा है? Null सही बोल रहा है? Who is telling correct? Null is saying correct or alternate is saying correct? Who is saying correct? ये तो चेक करना पड़ेगा ना भाई. ये तो टेस्ट करना पड़ेगा. बोल क्या रहे हैं? What they are speaking, what they are speaking, that's what we understood by ANOVA. But which one is correct? You have to apply a test. Okay, fine. So we have to take an example. Again, there is many theory written mention here. Okay, there is many theory written, but I'm not concerning about the theory. Let me talk about an example that will clear each and every concept of yours. So this is my data set. Now listen carefully. This is my data set. I need to apply ANOVA. I very well know about ANOVA. Null hypothesis, all mean are same. Alternate, not same. That's it. So if you want to know if the number of books read by each group is same or not, where each group is having 3 students. Okay. I'm having 3 groups. Group 1, group 2, group 3. Okay. And in a group there are 3 students. That's what it means, like, na? 3 students are there. This is student 1, this is student 2, this is student 3. So student 1 in group 1 study 1 book, student 2 in group 1 study 2 book, student 3 in group 1 study 5 book, and so on. सेम हियर ऑल्सो, ना भी वही है। आपको तो ये बताना है कि भाई इसका मीन एंड इसका मीन इक्वल, वो नल हाइपोथेसिस है, और नहीं है तो अल्टरनेट। ओके, सो देर आर सम स्टेप्स टू बी परफॉर्म्ड using ANOVA. Step number 1, find the grand mean. Find grand mean. So this is x1 bar, group number 1, mean 1 plus 2 plus 5 divided by 3, 2.67. Okay, so this is group 2 mean 2 plus 4 plus 2 by 3, 2.67. And this is 2.2 plus 3 plus 4 by 3. This is mean of group 3. And you have to find actually grand mean. ठीक है, ग्रैंड मीन निकालना है, तो वो x1 बार प्लस x2 बार प्लस x3 बार डिवाइडेड बाई 3, 2.78. So you have to add all the mean and then find the new mean, that is the grand mean. Step number 1. Okay, you got the grand mean. Now step number 2 is degree of freedom. Degree of freedom, I think I have already told you. Degree of freedom, when I was talking about the gamma function, I told you about the degree of freedom, how features are independent of each other, that is degree of freedom. Okay, so you have to calculate the degree of freedom between the groups and within the groups. Okay, between the groups and within the groups, you have to identify the degree of freedom. So between the groups, actually I am having three groups. So the formula for degree of freedom between the groups is k minus 1. So value of k is 3. So 3 minus 1 is 2. This is between the group degree of freedom. Okay. Within the group degree of freedom formula is n minus k. That is number of data points minus number of groups. So there are actually total 9 data points. There are 9, na? In each group we are having 3 entry. So total 9. So 9 minus 3 is 6. So that is the degree of freedom between the group, and this is within the group. N minus k. Okay, got it. This is step number 2. Okay. Step number 3. You have to find a critical value. F value. F. F वैल्यू, क्रिटिकल वैल्यू। अरे भाई अब ये कौन सी मुसीबत आ गई, ये एफ वैल्यू कही होती है। व्हाट इज दिस एफ वैल्यू? ओके, नाउ चेक आउट व्हाट इज दिस एफ वैल्यू. Actually we call it as f statistic, f value. That means it calculates the value comparing between group variability to within group variability. That means it indicates significant difference between the group. To find the difference between the group, we are going to look out for the f value, f statistic value. Okay, so f statistic, it compares between the group variability and within the group variability. Okay, between and within the group variability, that is your f statistic. Okay, so here it is, f. So between the group divided by within the group, between the group variability divided by within the group variability, that is f. So if f statistic, what the interpretation says, if f statistic is greater than the critical value, there is some critical value, and for critical value we are having already existing table. We are already having a table. We'll check the table. Okay, we'll check the table. Fine. So If f statistic is greater than the critical value, we are going to reject the null hypothesis. And if the f distribution, there is a critical region in the right tail, determine if there is a significant difference. That will check कि अभी क्या आ रहा है, देखते हैं. Let's see. So here is a table. Like na, this is a statistical table actually. Just like in our schools, we have seen log table. In engineering, we are having many tables. Okay, reference tables. Similarly, here a statistical table is there. Okay, so step number 3 is find the critical value of f. Okay, now how to find the critical value of f? Let us consider that the significance level is 5%. Let us consider in question it is given that the significance level is 5%, 0.05. 5% is 4.05. So f critical is given as degree of freedom between divided by degree of freedom within. Between to within. अच्छा ये कहाँ से आ गया सर, ये 5.14 कहाँ से आ गया? चलो दिखाते हैं तुम्हें 5.14 आया कहाँ से, फ्रॉम वेयर इट केम. नाउ चेक हियर. This represents degree of freedom for the numerator and this represents degree of freedom for the denominator. Okay, numerator to the denominator. Okay, fine. So degree of freedom between how much degree of freedom between came 2, and how much the degree of freedom within came 6. So 2 by 6 between by within. Okay, between by within 2 by 6 degree of freedom 2 and 6. Okay, this is a 2 numerator, this is 6 denominator. Kindly check this value. If you can see, I don't know whether you can see or not, it is 5.14 mentioned. Yeah, 5.14. Okay, let me increase the size. Now you can see it is 5.14. So this is how we can calculate f statistic. And this table is already given. ये स्टैटिस्टिकल टेबल पहले से दे रहती दी रहती है आपको. अपन को कोई फोकट लफड़े नहीं करना. Okay, so numerator by denominator. Degree of freedom between divided by degree of freedom within. तो between जो है that is the numerator, within है denominator. And this is, we just verify with the table. That's it. Okay, so 5.14. Okay, fine. 5.14 it came. Now step number 4. Find sum of squared total. Sum of squared total. Now how to calculate the sum of squared total? That means sum all over the data points. That is summation. And this is how you have to do. Yi minus y bar ka square. That means each data point minus grand mean. This is what you have to calculate. SS total. Sum square total. So every data point minus grand mean. Okay. So you are having 9 data points, na? And grand mean is 2.78. So subtract grand mean from each and every value and do the square. Take the summation. It came to be like 13.6. So SS total is 13.6. Okay, and then what you have to do? Find the sum square within the group. पहले तो ये ग्रुप का निकाला, ओवरऑल ग्रुप का निकाला. अब विद इन द ग्रुप का करेंगे. दिस इज विद इन द ग्रुप. दैट मीन्स नाउ यू आर नॉट गोइंग टू कंसिडर द ग्रैंड टोटल. ये पहले ग्रुप का मीन है, दिस इज सेकेंड ग्रुप मीन, एंड दिस इज थर्ड ग्रुप मीन. सो सब्ट्रैक्ट मीन फ्रॉम द रेस्पेक्टिव ग्रुप वैल्यू. तो ये आपका ग्रुप नंबर 1, दिस इज ग्रुप नंबर 2, एंड दिस इज ग्रुप नंबर 3. So this is the mean for group number 1. This is mean for group number 2. This is mean for group number 3. So SS within. पहले तो ग्रैंड मीन को माइनस करा सबसे, वो अलग चीज हो गई, दैट इज एस एस टोटल. नाउ यू आर सब्ट्रैक्टिंग द मीन ऑफ द ग्रुप, respective group, from the respective value of that group. That is called as SS within. And then what you have to do, find the sum of the squared between SSB. So SSB is calculated as total minus within. So 13.6 minus 13.34. Answer is 0.26. So subtract total minus within. Answer is 0.26. Okay. Now, after getting this SS between, this is SS between, step number 7, you have to find the ratio of mean squared, that is between, and mean squared within. So for that you have to divide SS between by degree of freedom of between. So SS between is 0.26, degree of freedom was between of was 2 for the between, answer is 0.13. SS within, it came to be like 13.34, degree of freedom in within is 6, so it is 2.22. Then you have to find F statistic value, that is the ratio of these two, that is 0.13 divided by 2.22, answer is 0.58. Okay, 0.58, 0.058. This is F statistic. Okay, and the critical value we have already seen from the table, that is 5.14, and critical value is greater than this value, 0.058. So F statistic is less than the critical value. So if F statistic is less than the critical value, in that particular case, we fail to reject the null hypothesis. That means all the means are same. That means null hypothesis is correct. That means this null hypothesis is correct. These are the steps, 7 steps to perform ANOVA. Okay. So ANOVA is very important concept in statistics, used in data science to solve many of the problems. Okay, let me revise this thing again. Okay, so let me revise this thing. You are available with three groups, three students, what they study, number of books. You are available with three. Okay. Step number one, grand mean. So find the mean of each and every group and then find the grand mean, 2.78. After that, calculate the degree of freedom. Between and within. Between between k minus 1. That means number of group minus 1. 3 minus 1, 2. Within 9 minus 3. That means number of data points minus the number of groups. So 6. 2 by 6. 2 and 6. So this is the degree of freedom numerator. This is the degree of freedom denominator. Check the value from the table. So according to the table, the critical value is coming to be 5.14. 5.14. Okay, 5.1. Then what you have to do? Then subtract grand mean from each and every value. That's what you have to do. Subtract grand mean from each and every value. You got 13.6. Then subtract mean from each and every value, respective mean. You got 13.34. Then 13.6 minus 13.34. That's what you have to do. Okay. So you are getting 0.26. This is SS between 0.26. Then divide SS between by degree of freedom between, 0.26 by 2, 0.13. SS within by degree of freedom within, that is 13.34 divided by 2.2. Then take their ratio also. इसका भी ratio ले लो. 0.13 divided by 2.22. Answer is 0.58. Now compare with the with the critical value. Critical is 5.14. Your value is coming 0.058. That means it is less than 5.14. Point is over. That means null hypothesis accepted. This is a ANOVA. Null hypothesis accepted. That's it. Okay, got it. Okay, so it's a very important concept in statistics, ANOVA. If I need to analyze the variance between the different groups, I will be applying ANOVA. Okay, so you may see a distribution of a group like this, like this, like this. There could be different groups. There could be different sample S1, S2, S3. I need to check whether the mean of S1, mean of S2, mean of S3 are same or not. ये null hypothesis. This is null hypothesis. If it is not same, alternate hypothesis. Okay, fine. So there are various types of ANOVA. One way you have already studied above. There are different types of ANOVA. Like one way ANOVA. This is a basic form. The one which you studied right now is a basic form. It is used when there is one independent variable with two or more levels of group. Okay, it compares the mean of these groups. If there is any significant difference between them or not. Then we are having two-way ANOVA. There are two independent variables. So in one way, one variable. Two way, two variable. It examines the effect of two factors on the dependent variable with their interaction. That means studying the influence of both gender and age on the test score. So we are doing a study based upon gender and age. So there are two variables, two factors on independent variable. Effect of two factor on independent variable. So gender and age, these are the two factors, and I'm going to take these under consideration to check how it impacts the test score. This is two-way ANOVA. Factorial ANOVA. Okay, it extends the concept of two-way to include more than two independent variable or the factors. That means investigating the effects of gender, age, and education level on job. Now I am having gender also, age also, education level also. Okay, all these I am having, and I'm looking forward to find the impact on the job satisfaction. This is factorial ANOVA. Then we are having repeated measure ANOVA also. So repeated measure ANOVA is a type of ANOVA which is used when the measurements are taken on the same individual or the subject over multiple time points or the condition. For example, I'm checking the blood pressure of patient in the morning, then I will check in the afternoon, then I will check in the evening, then I will check in the night. That means same test I'm doing over a patient. I'm looking forward to find the blood pressure at different time interval. This is repeated measure. This is repeated measure ANOVA. Okay. Then mixed ANOVA. That means combine subjects and within the subject. That means it is used when there are both independent group and repeated measure. So group are also independent and repeated measure is there. That means effect of a training program is it is independent group and the time repeated measure on athletic performance. This is mixed ANOVA. I'm mixing. I'm combining ANOVA methods. So repeated also, and general ANOVA also. So this is mixed ANOVA. I am having MANOVA also, multivariate analysis of variance. MANOVA. It extends the concept of ANOVA when there are multiple dependent variable. Okay, multiple dependent variable. For example, comparing the effect of different teaching methods on students' academic performance across multiple subjects. This is MANOVA. Okay, multiple dependent variable. I'm sometime I'm teaching with this mode, sometime I'm teaching with another mode. I'm going to check how the student performance is going on. If I change the modes, what result it is giving? That is MANOVA. Then I am having ANCOVA, analysis of covariance. It combines ANOVA with the regression analysis to control the effect of one or more covariates. For example, examine the effect of new teaching method on test score while controlling the student IQ. Okay, this thing has not been like not to be understood. Controlling the student IQ. How we can control the student IQ? How? So just okay. Don't consider that thing. How you can control a student IQ? Okay. So they are saying that you are going to perform regression analysis. Regression. Okay, I will be teaching ahead what it is. So there are various ANOVA tests depending upon the problem statements. Okay, one way ANOVA, two way ANOVA. Okay, that's what you have seen. One way, two way, factorial, repeated. These are okay known ANOVA methods. Okay, mixed. Okay, these are known ANOVA methods. And how you calculate the ANOVA? I already gave you an example. We already solved a problem statement for ANOVA. Null hypothesis, all mean are equal. Alternate, it is not true. This is what we have already seen. Already seen. SSB, SSW, SST, all. Okay, now these things look like a different thing or odd thing, but in above example, we did this only. Okay, यही करा था अपन. Degree of freedom between is k minus 1, within is n minus k. Degree of freedom total is n minus 1. So between and within, I already told you. Degree of freedom. Okay, that's also we have seen. Okay, fine. This is ANOVA. What are the limitations of one way ANOVA? What are the advantage and disadvantage? See, one way ANOVA will help you to determine whether two or more groups have different mean or not. That means, are they different from each other or not? But it will not tell you which specific group differ from another. It will let you know that whether, okay, we are having three samples S1, S2, S3. The ANOVA will let you know whether they are different or not different, but it will not tell you which one is different from which one. ये नहीं बताएगा वो. This it will not tell. Okay, it will tell whether the distribution of these three is same or not. If it is not, then between whom it is not same, it will not tell. That is the limitation of ANOVA. Okay, got it. Fine. All right. So this is ANOVA. Okay. So that's what we have seen in the example, and there is advantage. It's a very simple approach, ANOVA. Okay, and it enables us to have evidence-based decision making crucial for scenarios with multiple treatment options. It's a good thing. ANOVA. Okay, fine. So now let me talk about advantage and disadvantage again. Here it is. Advantage. It can handle multiple group. Okay, doesn't matter how many groups you are having. One, two, three, four. As many as groups you are having, it can handle. It allows us to test the difference between groups. Okay, to find the difference between the groups, it allows us to perform the testing. It provides information about the variability within the group and between the group. ये सब है अपने पास. That's what we have seen. Between the group, within the group, degree of freedom, everything. That's what ANOVA will help us in identify. That is the advantage of ANOVA. Disadvantage, I already told you that it does not identify which group differ from another group. ये नहीं बता पाएगा वो, ये तो बता देगा कि अलग है. ANOVA will let you know that there is a difference in the distribution, but between which group the difference occurred, it will not tell. That is the disadvantage. Also, ANOVA assumes that data is normally distributed. If your data is not normally distributed and you are applying ANOVA, then you are doing absolutely wrong. Unless and until you don't follow the requirements of an algorithm, you will fail. भाई गलत सलत कर देगा वो. So it assumes that data is normally distributed. So you have to first make the data normal. Okay, data normal, and then apply ANOVA. ANOVA does not provide information about the strength, of relationship between dependent and individual. This is also not been given by the ANOVA. What is the strength of relationship between dependent and independent variable? That's not given by ANOVA. Okay, so it just only let you know that whether the groups are dependent, means whether the groups are having the same mean or not, same distribution or not. Okay, so same mean, null hypothesis. Okay, and then if it's not having the same mean, then alternate hypothesis. That's what ANOVA tell. Okay, it will not tell between whom the difference occurred if alternate hypothesis is correct. Also, it does not provide any information between the strength and the relationship between independent and independent variable. Distribution should have to be normal. This is the disadvantage of ANOVA. Okay, fine. So one numerical example we have seen over the ANOVA, and you will be getting same kind of like problem statement. You will be given a data set. Okay, you will be given a data set, and you have been asked kindly apply ANOVA over it. Kindly test whether the distribution of these samples are like same or not. So we do perform random sampling from the population. We have to apply ANOVA for that. And what I got to understand from this thing is you are having features which are numerical and it should be continuous in nature. Then only you can say that it's normally distributed. तभी तो होगा. So ANOVA is applied over numerical data, especially continuous in nature, especially normally distributed. So understand technically over which I can apply ANOVA. It's not like that, okay, you are having categorical data and you are applying ANOVA. That ANOVA is not applied on categorical data. ANOVA is applied upon numerical data, continuous data, which is normally distributed. That is the assumption. Okay, that you have to follow. So this is about ANOVA, analysis of variance. Okay, fine. Again, today also you guys were listening very sincerely. Let me